Um, Hi, today we'll be discussing about Apache Hadoop framework. Apache Hadoop framework is a very good framework for processing huge volumes of data. For processing huge volumes of data. Wait a minute. Do that. Yes, we can actually process huge volumes of data using Apache Hadoop. We can use this Apache Hadoop along with the Java, and we use this framework in one of our projects. So basically, Apache Hadoop is processing big data. If you see it actually follows the map-reduce programming model. I want to explain a little bit what is the map-reduce programming. Um, Wait a minute, map-reduce. You see, MapReduce is a programming model associated with implementation, processing, and generating big data sets with parallel and distributed algorithms. So, MapReduce program is nothing but a simple program, composed of map procedures. It basically performs filtering and sorting kind of logics. You need to implement MapReduce. The core logic and underlining the behavior of the MapReduce is generally when we execute the program, it will get executed on your local machine, your server, right? Let's say in distributed environment, you want to perform a task, you want to do the computation of huge volumes of data, and the data is resided on multiple servers. Imagine. Then instead of executing your program on your machine, you are going to send your MapReduce program to all the nodes wherever the data is distributed, and that program will get executed on that particular local machine parallelly. All this, the MapReduce program will get replicated in all the programs, and the MapReduce program will be executed in all the nodes, and it will collect the data, it will aggregate the final result, it will provide the result. What it is doing, that way it will reduce the latency, it simplifies the computation process. In a lesser time, you would be able to process a huge amount of big data using a MapReduce model. So that is why MapReduce. So let me show you the diagram MapReduce architecture. You can see here. Is this? See, when we are giving a input, it's splitting it, and the map. What is doing the map logic? It is mapping all the data. It is executing the logic, and once the logic, once the data is processed, it is shuffling and aggregating the data. You see, and finally it is going to give us the output. It is very simple. We are just splitting the input. We are splitting the input, and our mapper program it will get executed on particular data node, and finally it will shuffle it. It will reduce the data, aggregate the data. It will merge the values, and it will give us the result. It is very simple, right? The underlying logic is very simple. And now you come to the point here. You can see there is another program here. Before this, I want to explain what is a task tracker or name node. There are a couple of elements, components you want to know about the Hadoop. If you see Hadoop, it was initially released in the year 2006. Okay, April 1st, initial release. And architecture, let us go into the architecture. You can see the map reducer layer and HDFS layer. HDFS is nothing but a file system. It's a for distributed file system location where the data will get stored. For processing data. We will have different components here. Basically, MapReduce will work as a master and slave model. Master will contain a name node, data node, a job tracker, task tracker. Slave node will contain a task tracker and data node. So I want to explain a few things here. What is a Hadoop distributed file system? Hadoop distributed file system is a distributed and scalable portable file system. It was written in Java for Hadoop framework basically. Hadoop instance is divided into HDFS and MapReduce. MapReduce is a program. As I told you, it is a program where it will run on multiple nodes and it will actually compute the logic, okay, and then it will shuffle, it will aggregate the result as a final output. Hadoop distributed file system is a file system for storing a data. Once the MapReduce is used for processing the data, it requires the data, right? So the data is generally captured from the HDFS file system, or it can be stored in the HDFS file system. Okay. You see, there are 5 components here: name node, secondary name node, job tracker, data node, task tracker. Name node is basically a master node. Okay, it is generally used to track the files, manage the file system, and the metadata of all stored data. Okay, it is basically master node. Data node stores data in data blocks, right? Is also known as a slave node, right? You see, it stores the actual data into HDFS file system, which is responsible for the client to read and write. Okay, these are the slave nodes basically. Every data node sends a heartbeat message to name node every 3 seconds to convey that it is alive. Okay, data node is the slave node, name node is the master node. Secondary name node take care of the checkpoints of the file system metadata, which is in the name node. Okay. Job tracker basically it receives the request for MapReduce execution from the client. So when the client has written a MapReduce program, he wants to do some logic, he wants to do some computation. He has written some MapReduce program. Then this job tracker is basically receives that request from the client. Okay, it talks to the name node to know about the location of the data that is used to process it. So the name node, job tracker, and the task tracker, it is a slave node for job tracker. It will take the task from job tracker. So as I told you, Hadoop basically is a cluster kind of architecture, right? It will have cluster of nodes. It will have cluster basically normally is a single name node plus cluster of data nodes. Then it is a single name node, cluster of data nodes. So the MapReduce, the program will be sent to the data nodes wherever the logic has to be executed. The program has to be executed in the wherever the data is reside. Data may be residing in 1,000 data nodes, right? Or 10,000 data nodes. So for all the data nodes, the MapReduce program will be distributed, and the MapReduce program will get executed over there. So underlining logic is what is happening here. Generally, you take an example of JDBC. What happens when you write a simple Java program with a JDBC? The program will execute in your server location, right? And it will talk to the database server. So it will pull all the data from the database server. So you see, for pulling the data from database to the server location, there will be a latency. The data has to travel, right, over the network. So if it is a simple data, a simple volume of data, no problem. It is millions of records, so petabytes of data is there, terabytes of data is there. So how do you handle that data? It is very difficult. That is where the MapReduce was introduced. So in the distributed location in the cluster environment, your program will not get executed over your server. Rather, it will be sent to all the data nodes, wherever the data is presented. So there each program will get executed, and it will collect the data, and the final data will be aggregated after the shuffling, right? So that way the data will be processed, it will be aggregated properly. So that's how we have to write the data MapReduce programming. So underlying programming, we split the task button, and each and every MapReduce program over the data nodes, they will parallelly execute and parallelly perform the task, parallelly finish the task, and they will finally aggregate the result, and they will provide the result. So that is the significance of the MapReduce program. Okay, HDFS, Hadoop Distributed File System, it is a file system. You need to mount particular file system to store the data. MapReduce is a program. Okay, that is why it is consisting of two major components. One is distributed file system, HDFS file system. Other thing is MapReduce program. Okay, so this is how you can do that. You can see the job tracker and the MapReduce engine. Basically, as I told you, once you have written the program, it will be the MapReduce program. This will be received by job tracker and will be given to task tracker. Task tracker will get executed on each and every node. And there are some components, Hadoop, by default Hadoop uses first in first out scheduling. Okay, for managing the jobs. There are so many other components. Yet another resource negotiator is also there. It allocates the resources to various applications effectively. It runs the demos which take care of two different tasks. In order to run your complete Hadoop ecosystem, this cluster, you need to make sure these corresponding components are up and running. Okay, you have to make sure all these things are properly set up. Then only your Hadoop cluster will get executed. Imagine one thing, just for information, you have to use the Hadoop framework whenever you are going to deal with a huge data, big data, and you want to process the data, you want to aggregate some results, and for data analytics, you want to analyze the data. In those scenarios, you can use the Hadoop framework. That is a good option for you. Or if you want to perform, in case if you want to perform transactional related queries and all, Hadoop is not suitable for that. Hadoop basically it is a batch kind of job. Once you submit the job, it will take some time to run over the data, huge volumes of data. After the program finished, then it will aggregate all the data, it will aggregate all the results, and it will give all analytical information on the data. So this is how we can use it. And we have a Spark also. I will discuss about the Spark later, but for now, Spark is also kind of MapReduce, follows the architecture, but it is a little bit faster because it runs on the RAM of the system. It basically runs on the RAM memory of the system. It is a little bit faster. I will explain that later. For real-time processing of the data, they will use the Spark. But if you want to process huge volumes of data in batch mode, in offline mode, you want to analyze historical data, huge volumes of data that was there for the past couple of years. For example, you take a bank or you take e-commerce application. They want to analyze the historical data, how the company performed over the past 20 years or the past 15 years. So they want to see that, and the data was there in the data files. How do they do that? If they want to do analysis and do these things without the Hadoop program, it will take a lot of time for them. Maybe it will take years for them to understand and analyze that. right, with normal programming. But the thing is, with a Hadoop, you can do it in a days, right? You can do it in hours based on the data, right? You can do it very simple. So that is how we can use the Hadoop framework. It is a very good framework, and it was written in Java. You can see it is very supportive, right? That is why most of the companies they still using it. Even in data analysis, right? Nowadays, artificial intelligence, data science, we are actually hearing these buzzwords. What is happening here? For data science, they need to analyze the data. They have to process it. For data mining scenarios, also they are using this data. They are using this MapReduce program. So many companies are still using Apache Hadoop framework for processing huge volumes of data. Right? Do not forget that. So it is very good framework. It's still dominating other frameworks. When they want to process huge volumes of data, petabytes of data, Hadoop is a very good framework, and the underlying architecture, the algorithm, basically this algorithm is still dominating when they want to process huge volumes of data. Right? They are still using the Java. Many companies they are setting up the Hadoop cluster. They are setting up the entire ecosystem. They are running Hadoop MapReduce jobs. They are writing MapReduce jobs. You can write the MapReduce jobs in Java, Python, or any shell script. You can write it. It doesn't matter. You need to set the Hadoop cluster in such a way that it can process your data. Okay, and thanks a lot, and thank you for listening to this video. I hope you understand what is this Hadoop, and next we are going to do this. In the next video we'll discuss about Spark and other frameworks. Thank you very much.